Good day, everybody. My name is Kelechi. I'll be taking chemistry jam. Now, I believe that one of the other we started studying for jam. Say jam's exam is next year. I believe this is the ideal time for us to start working on our basic courses. But first of all, we need to start on the foundation of everything. And we need to understand the basic things in chemistry. Now, one of the topics under chemistry is chemical combination. It's just English, more like bonding. Now, we observe something in our periodic table. For those that have periodic table, you observe one thing in your periodic table, that you observe that elements are arranged in increasing order of atomic number. That is from the left to the right. So you observe that you look at the second period, we have lithium, for example, you have beryllium, you have boron, carbon, nitrogen, up to neon. Normally, this is what we have. Now, these are elements. And we observe that we go towards the right, as atomic number increases, we observe that there is filling of electrons as you go to the right. That means you're adding one new electron to the shell. And that is something I'm trying to bring out here. We have what they call shells. Shell. What is shell? You can recall that lithium has a configuration of 1s to 2s1. Let's not forget that our basic shell, what you learn is what the K, L, M, N shell. Now, in the K element shell, we can easily deduce that the K can hold 2 electrons, L can hold 8, M can hold 16, and N can hold 32. So someone now asks, how am I getting these numbers? I'm not manufacturing these numbers. It's from 2n squared. 2n squared. So K is the first shell. N there means number of shell, 1. So K is the first shell. So N is equals to 1. So 1 square will give us 1. So 1 times 3 is 2. L is 2. 2 square is 4. 4 times 3 is what? 8. As you go M and N, same thing too. So what I'm bringing out there is what is shell. Now, back to this element. Fine, this element, they are in the periodic table. But we observe that this element, they combine together to form compounds. And the big question is, how do they do that? Why do they do that? They do that why? Because they have to attain what they call a stable octet or a stable duplet. And we observe that the octet structure, which is when we have 8 atomos shell electron, while duplet is when we have 2 atomos shell electron. When we have that, we can easily say that such element is stable. For example, now, lithium, it has 1 electron in its atomos shell. Beryllium has 2. Boron has 3. Like I said earlier on, as you move towards the right, electrons are being added to the shell. Now, elements will always look for ways to achieve the stable state, which is known as either the octet or the duplet state. And that is why they undergo what they call bonding. Why do they bond? Why? Because they want to achieve a stable state, which is what? The duplet or the octet state. Now, we now need to know, how is it possible? We have what they call types of bonding. And the types of bonding is what we have here. Electrovalent bonding, covalent bonding, and under covalent bonding, what they call dative bonding. So we will try to expose ourselves to bonding like this. So we'll start with the first one, electrovalent bonding. Now, electrovalent bonding is something that we need to understand very, very well. Very, very well. Now, let's consider shells. We are going to be using shells in the course of this bonding. Why? Because we want to explain the types of bonding we have here. Now, the electrovalent bonding itself, what is the electrovalent bonding itself? It involves the transfer of electrons. It involves what? The transfer of electrons from an atom to another atom. Please note, many textbooks will be telling you different definitions. Please note, the transfer of electrons from an atom, the first atom that can transfer is a metal. So So a metal is what transfers electrons. So a metal transfers electron to a non-metal. A metal transfers electron to a non-metal to form what they call an electrovalent compound. Electrovalent bonding can also be called ionic bonding. Please note that it can also be called ionic bonding. So two things is happening here. Let's observe. One, the transfer of electrons. And two, when the electrons are being transferred, you observe that an ion is formed. So when I transfer an electron, an ion is formed. So now, fine, the transfer of electrons is from a metal to a non-metal. They will now ask ourselves, what is the ion that is formed here? What are we trying to say? Now, the ion we're talking about here are the metals and non-metal. That is, when the metal loses an electron, it becomes what they call a cation, a positively charged ion. That is called what? A cation. While a non-metal, when it accepts this electron, it becomes an anion. And we need to understand some basics in there. A cation and anion. So a cation is a positively charged electron, and an anion is a negatively charged what? Ion. So what happens is that when they both accept and is when they both transfer and the other one accepts, then we have what we call attractive force between them. That is positive and negative. And we need to recall that what? Unlike charges, will attract. And that's why we can also say that ionic bonding is also the involves what they call Coulombic attraction. Because you are attracting a positive ion to a what? To a negative ion. They get attracted. So Coulombic attraction. Now let's take an example of a metal. If you look at a barbie, for those that are looking at a barbie, the first thing you see on a barbie is sodium and chlorine. Very, very popular example. Sodium and chlorine. So sodium and chlorine is the most popular example that you can see in your in the example there. But let's try something. Let's do something different. Not like let's do something different. I want to explain based on their shell. Let's use sodium is 11. Potassium is 19. So potassium is 19. So let's do K plus F. Potassium is 19. That is what? 2,8, 10, 8, 1. That means we have 2,881. Fluorine is 9, 2,7. Now, let's look at the shell. We know that the atomous shell of potassium will contain one electron. Fluorine, the atomous shell will contain now. We observe that there's a complete transfer from here to here. And now do you observe what happens here? We have this left. If this electron goes here, we have nothing in the atomous shell. So it goes away automatically. Plus this, we have this. So we can really say that an electron here has been accepted by fluorine. And in that sense, we call this K plus and we call this F minus. K plus and we call this F minus. So K plus means that potassium has lost an electron, and F minus means it has accepted an electron. And they both combine together to form what they call KF. And that is what they call ionic bonding. Ionic bonding. And we need to understand what are the basic factors that can affect this. What can affect this bonding? Number one is what they call ionization energy. So we need to note that the metal must have what they call low ionization energy. Why the non-metal should have what they call high ionization energy. And what do you know of ionization energy? That is the minimum amount of energy required for what? An electron, required for an atom to lose an electron in its ground state. What is it? What are we trying to say here? That means if the metal have low IE, it means that it can easily give out an electron, which is what we want. A metal must have what they call easiness to give out a metal. If it does not have easiness to give out a metal, then there's a problem. We cannot say that such atom can form ionic bonding. So number two is what? High electron affinity. The non-metal must have what they call high electron affinity. That is, it must have high ability, or it must have strong ability to what? To attract electron to itself. Very, very important. To itself. And those are the factors that affect ionic bonding. That affect what? Ionic bonding. Now, next we need to consider is what? The characteristics of what? Of ionic compounds. Characteristics. Number one, structure. What is the structure? Ionic compounds, they form a structure that we need to know. And what is that structure? Is that they form what they call crystals. Crystals. So that's why you see your NaC, your salt, different salts you have. If you have been in the lab, most of your salts are in crystal form. They're in solid form. So they're in crystals. They're in crystals. So one of the characteristics of ionic compounds, number one is what? Crystals. They form solids, and that are crystals. Number two is what? High melting and high boiling point, and that is true. Ionic compounds are said to possess what they call high melting and high boiling point. Very, very important. Please note that. Number three is solubility. There's a saying we do say in chemistry is that like dissolves like. That is, you expect a solvent of the same property of the solute to dissolve each other. Fine. We learned that water is the universal solvent. That is true. But we need to note that we expect a polar solvent to dissolve a polar solute, and not the other way around. So we expect a polar solvent to dissolve a polar solute, and we expect a non-polar solvent to dissolve a non-polar solute. So we are not in. You need to know that in solubility for ionic compounds, all ionic compounds are polar in nature. Many of them are polar in nature, and that is the reason why that we observe that they dissolve what? That they are being dissolved in water. So the fact that this ionic compound itself are polar in nature, water can easily what? Dissolve them. And the next one again is what? Electrolytes. Beautiful. There's a basic school chemistry that is being done in schools. Is when I think you put a wire in lime or something like that, and you observe that it can easily ignite lights. It can ignite a bulb. Yes, it can ignite a bulb. So all those things is based on the fact that they are electrolytes. Ionic compounds can act as an electrolyte. Note, NaCl NaCl is not an electrolyte, but NaCl in water is an electrolyte. So that means an ionic compound in electrolytic form is an electrolyte, while ionic compound in the solid form will not act as what? An electrolyte. So that's why we need to note the difference between both of them. So ionic compounds are very, very good electrolytes, and we need to note that they are very good electrolytes. They should be able to what? To conduct electricity. Be able to conduct electricity. And that's one thing we need to know about what? Ionic what? Compound. So we said earlier on, number one, structure. Number two, high melting and high boiling point. Number three, solubility. Number four is electrolyte. Electrolyte. Very, very important, please. Very, very important. I believe that we are all following. The next we are going to consider now is covalent compounds. Covalent compounds. Very, very important. Covalent compounds. Covalent bonding, rather. So, what's covalent bonding? Let's recall. Ionic bonding, transfer. But in covalent bonding, what do we observe in covalent bonding? Is sharing. Oh, you don't have. Oh, yeah, come. Let me help you. Oh, you don't have. Come, let me help you. That is done in covalent bonding. So covalent bonding is a bonding that involves the sharing of electrons. Let's recall what you said. Let's look up, guys. Let's consider a non-metal, 2,7. And another one, 2,7. Let's another one, 2,8,1. This is bonding with this one, and this is bonding with 2,8,7. Now we observe that this is A, B. You observe that rather than this one here, rather than it to lose 7 electrons in atom shell, it will rather share with this. This does need one to become octet. In the sense that octet, in the sense that this becomes 8 electrons. And we know that in the octet state, there is extra stability. So if this is 8, how can we make this 8? To get 1. So it's easy for us to share between this and this. Than want to now transfer out 7 electrons. No, that is too much. No. But unlike this, I have 1. If I release this one, it can go here to form 8. So this one is ionic. This is what? Covalent. So in covalent bonding, it involves the what? The sharing of electrons. And that's why we need to note that we have what they call the types of covalent bonding. And the first one there is single. Let's consider hydrogen H2. Which is H on its own is 1s1. So you have 1 like this plus this. There's going to be what? Sharing. So you see something like this. Sharing. So you have shared electrons here now. And that is called what? Single covalent bonding. It can be oxygen. Example of another one again is what? Is oxygen. If I have O2, O2 is what? That is 2,6. So if this is, how can they share? Fine, I have something like this. This is what we have naturally. But we are now having 2 atoms of it. 2 atoms of this. 2 atoms of oxygen. I have 1 of oxygen plus oxygen again. And we have something like this. This is what will work better. Oh yeah, let's share. You need 2, Abi. Let's share together. I will share my own 2. You share your own 2. So in covalent bonding, you can only share what you have. You cannot share what you don't have. So this one has 2 electrons. It has 6, Abi. But I can share out 2. So let me share out 2. This one also share its own 2. So yeah, you share your own 2. So bam. So you can see that this is 8. This is 2, 4, 6, 8. 2, 4, 6, 8. Sharing. And this is what they call double covalent bonding. You can also have triple. Triple in the sense of what? Of nitrogen. Nitrogen is said to what? To have a triple covalent bonding. And that's why you have something like this. And bam, and because it's sharing out 3. You can try that at home. Oxygen is like this. And hydrogen is like this. So single, double, triple. Please, let's note this very, very well. Likewise, what we did in ionic bonding, we need to now ask ourselves, what are the characteristics of what? Of covalent compounds. The characteristics of covalent compounds. Number 1 is structure. They're not mostly solids, yes. They can be liquid, they can be what? Gases. Very, very, you need to know that very, very well. I look at the board, I didn't mention, I just came to my head now. The example that I use for this covalent bonding is considered by using same atoms. So you need to know that most atoms of the same, that is homo atomic bonding itself, most of them are what? Are covalent in nature. So note that very well. So you need to know that very, very well. So structure, liquid, gases, low melt and low boiling point is common here. Low boiling and low melting point is common here. They don't have it. Another one again is solubility. Most of the time they are non-polar in nature. Most of them are non-polar in nature. They are non-polar in nature. So they hardly dissolve in water, but they can dissolve in their fellow non-polar solvent. The number of non-polar solvent is what they call carbon disulfide, CS2, toluene, benzene. They are all non-polar solvents. Toluene, so example. Then electrolyte, they are not electrolyte, they are non-electrolytic in nature. They are non-electrolytic in what? In nature. And also, we need to now note, we said, please note, polar, non-polar. Polar is common in ionic, non-polar is common in what? In covalent bonding. Is covalent is popular in covalent bonding. Now, looking at this slide, I want to bring out something. Now, you see characteristics of covalent compounds. From what you can see here clearly, you can learn something today. And what is that? Is that we can easily understand something. Differences between the covalent and the ionic compound. I believe that I've taken the both concepts. So I want to quickly give it like a let's say 3 minutes for us to just come up with differences of our own choice. Simply type and send. Then I will come back to continue the class. Just 3 to 5 minutes. Thank you. come up with the differences, like I said, between covalent bonding and ionic bonding. So let's quickly round up that. Now, let's start with the difference. Number one, the difference there is that number one, the first one is that ionic bonding involves the transfer of electrons. But the covalent bonding, there's no transfer, we only share here. We only share. Secondly, we need to also observe that ionic compounds are good conductors of electricity. They conduct electricity very, very well. The other one, covalent bonding, they're not good. They're not good conductors. They are not good conductors. So these are things you need to also note. You also need to note about the high melting and high boiling point of ionic bonding, which is low in covalent bonding. The next one again is solubility. Many of them are what? They are non-polar. Ionic compounds are polar in nature, but covalent compounds are what? Non-polar in nature. So we need to also know that very, very well. Now, quickly, the last thing we want to talk about today is dative bonding. Dative bonding. Very, very important. This dative bonding, I'll just explain it in a very, very funny way. Let's say we have a boy, John. He's a very rich man, and he was walking back home one day, and he saw his friend Paul. I now said, Paul, where are you going to? Paul said he does not have a house and a place to stay. And John now said, wow, you don't have a place to stay. Yeah, come and stay in my house. And he brought all his old packages to John's house. And when he did that, he observed something that John told Paul. Paul was like asking John, what am I going to pay? He said, don't pay anything. Live here for free. And the thing there is that John is accommodating Paul without Paul paying any money. And that's what we do in dative bonding. In dative bonding, we have an atom or a group of atoms that accepts or that share electrons with and H plus. NH3 plus H plus. NH3 on its own self. This is NH3. This is NH3. NH3. This is hydrogen, nitrogen, hydrogen. So we have this. So one. So we have dots. Dots. Oh, sorry. This is a mistake. Sorry. So nitrogen itself has a lone pair. This is a lone pair of nitrogen here. This is lone pair. Now we now have H plus. H plus is now there. We now have H plus. But H plus does not have any electron there, but it wants to look for where it can bond. What happens there is that H plus can easily what? Go here. You can see arrow. So now you see arrow pointing to this. It's done in dative bonding. So you can either point to this or you can see something like this again. Just come, where you come. Let me help you. This is H plus. And this is what we call dative bonding. And what have we formed? We have formed what we call so this is it here. This is called NH4 plus. So this is called the dative compound. So very, very common. Or so dative bonding, or we can call it what? Coordinate bonding. Coordinate bonding. Coordinate bonding. So guys, we've treated this already. So I believe now we have been exposed to the various types of what? Of bonding. So we'll stop the class here today. And next class, we will see how we can dive into other topics in JAM. So I would like us to please go through this and feel free to drop your questions. Thanks for your time, guys. Do have a nice day.